In topic 4, we're going to be looking at graphs of relations and functions. So let's just recall and think back. How do we tell if a graph is a function? Well, we do a vertical line test on it. And remember, the vertical line test means if at any point the graph touches the vertical line in 2 places or more, it is not a function. So as you can see in the example here, they gave us a vertical line, and at this point it's touching the graph in 2 spots, therefore it is not a function. However, if you can get across your whole graph and only touch it in 1 point at a time, then it is a function. So in example 1, it says this graph shows the approximate height of the tide, h meters, as a function of time. So we have time over here, and then the height of the tide over there. Identify the dependent variable and the independent variable. Justify your choices. So if you recall from topic 2, we said that the independent variable is always the x value. And remember, this is the x-axis here, and this is the y-axis. So in this case, the independent variable is the time. And we can justify that choice by saying nothing affects time, so it's independent. Therefore, the dependent variable must be the height of the tide. And that's because the height depends on what time of day it is. Therefore, it is dependent on the independent variable. So now let's see, why are the points on the graph connected? Explain. So the reason we would have points on the graph connected is because the tide doesn't just jump from 9 a.m. at this height all the way to this here. So what would this be? 10 a.m., 11, 12, 1. Yeah, so this would be 1 or 10 a.m., sorry. And it doesn't just jump to 1.2 meters from 0.8. It's going to move and hit all of these times and heights in between those 2 points. So that is why the graph or the points are connected. So we're going to say that the tide is continuously moving higher and lower. It doesn't jump from one height to another. It reaches all in between. So you could state this in a bunch of different ways. This is just one way to state it. As long as you somehow portray to me that you understand that the graph is going to hit all of these points in between these big points on the graph. So next, let's see, is this relation a function? Why? Well, let's do our vertical line test. Now, I don't have a vertical line to run across the page, but just imagine you take your pencil and you go across the whole graph like so with your vertical line, and you don't have to write on your graph, but you would get across the entire graph, and never will that vertical line hit the graph in more than one spot. Therefore, yes, it's a function, and it's because it passes the vertical line test. So moving on to example 2, the relation between x and y is linear. Linear means when we graph it, it'll be a straight line. So it'll be a straight line. And we'll see that right away. So graph this function using the table. Which number would complete the table? So if you remember doing the linear relations unit in grade 9, you would look for patterns in this table. So the x values would go up or go down by a certain number every time, and then the y values would do the same thing, but they would go up and down by a different number. So for instance, if we look at these x values, to get from 3 to 7, we added 4. To get from 7 to 11, we also add 4, and so on. So adding 4 works for all of these x values. Let's see if we can find a pattern with the y values. So to get from -3 to 2, we add 5. To get from 2 to 7, we also add 5. Therefore, we're going to add 5 to 7 to get this blank. So 7 plus 5 is equal to 12. So that there would be the missing blank. So now we can actually graph these points. Just like we did in topic 2, we changed a table. So this is a table that we have right here, and we moved it into a graph form. So we have x and y coordinates. So let's put our x-axis down there and the y over there. And let's label these points. So I'm just going to go up by 2. So this is going to be 2, 4, 6, 8, 10, and so on. And here we would have 2, 4, 6, 8, 10, and so on. So if we want to graph x at 3 and y at -3, so here I'll put some more values going down the graph. So we're going to go to x 3 and then y -3. So that point's going to land right here. And remember, every point we put on the graph, we want to label it. So I'm going to label this as 3, -3. And let's do the next one. We have x at 7, y at 2. So that would land right there. So we have 7, 2. Then we have 11 and 7. 11 and 7 would be here. And so on. So I'm going to continue graphing these or plotting these points, and then I'll cut back. There we go. So I plotted all of those coordinates onto the graph. And finally, our last step is to connect these dots. So try to use a ruler if you have. I don't have one on this app I'm using, so I'm just going to connect them in the straightest line I can. And there we have it. That is the graph of this relation. In example 3, it says, this graph shows the height of a burning candle and how it changes with time. What are the independent and dependent variables? Well, again, just like the last example we did, we have x and y, and our independent's always on the x-axis. So again, the independent variable is time, and therefore the dependent is going to be the height of the candle, because the height of the candle depends on how much time has passed. Write the coordinates of the points where the graph intersects each of the axes. So we have the horizontal, the x-axis there, and we have the vertical axis here, or the y-axis. So they want the coordinates of where our graph touches both the x-axis and the y-axis. So we have a point right there, and we also have the point up here. So let's start off with the x-axis. So if we're looking at where this graph touches the x-axis, it touches right there. And that would be at the point or at the coordinate, well, the x value would be 45 and the y value would be 0. So that's the coordinate where it touches the x-axis. And again, we'll do the same thing for the y-axis. So the x coordinate of that one would be 0. And now the y coordinate, well, this is going up by 2. So 2, 4, 6, 8. So this point here would be 10. So 0, 10 would be that coordinate. And finally, it says determine the vertical and horizontal intercepts. What do these points represent? So this question is actually similar to B. So let's start off with the horizontal intercept. So where the graph intercepts the horizontal axis, it's exactly where we said up here. It's at 45. So I'm going to put x is equal to 45. That's where it intersects the horizontal axis. What does this point represent? So if we're reading our graph, the candle started with a height up here at no minutes past, but as the time went on, the candle slowly and slowly got shorter and shorter. It burnt down. So all of a sudden, when we get to this intercept here, the candle has a height of nothing. So what that would represent is it took 45 minutes, because that's how much time passed, for the candle to completely burn. So at 45 minutes, there's no height to the candle, so it took that long for it to burn completely. And now let's look at the vertical axis. So where that intersects is at y is equal to 10. So at that point, no time has passed, and the candle has a height of 10 centimeters. So what this is representing is the candle was initially 10 centimeters tall. And that's all you have to answer for these ones.